Implicit differentiation comes in handy when you come to related rates. When you have related rates, you have to take the derivative of something with respect to time, with respect to t, and the variables don't always agree. So it's the idea behind implicit differentiation that leads us to the practical stuff like related rates. Okay, we're going to take the derivative of these with respect to x. And again, implicit differentiation leads us to other things, but it's a practical way of taking a derivative of something that may not necessarily be a function. This one actually can be solved for y easily, and the next problem can as well, very easily. However, there are times where you can't. And in such a situation, the derivative would have to be taken implicitly, like this. We're going to take the derivative of this with respect to x, which means we're going to d dx, everything. The derivative of x is 1. The derivative of 4xy involves the product rule. Don't panic, it's not that bad. We're going to let that part be f, and that's going to be g. And we're going to have f prime g plus f g prime, and we'll get to the rest of it later. We'll take care of that 4 when we get to that 4. But in the meantime, f prime, derivative of 4x is 4. The derivative, just g. Just g, not the derivative of g. Straight up g, it's y. Plus f, I'm going to keep f the way it is, g prime. And this is where it gets tricky. We need to take the derivative of y. When we take the derivative of y, it becomes 1. And then it's also, because this is an x and this is a y, because they disagree, we're left with this, dy dx. Mr. Reader, why didn't the dy dx happen over here? Because we did not take the derivative of y. We just straight up took y the way it was. Equals the derivative of 4, which is 0. Okay, our mission is to solve for dy dx. We want to find the derivative. So we're going to take those two terms, move them to the other side. So we have 4x dy dx equals -1 minus 4y. Oops. Oh, we'll go with it. -4y minus 1. Not a big deal. Change the order of that. Won't kill anything. We're going to divide by 4x. Those cancel. dy dx equals -4y minus 1 over 4x. There we go. That's the first problem. The second problem is going to involve the chain rule just a little bit. We're going to do some chain rule stuff in our head. It's not going to kill you. What doesn't kill you makes you stronger. I'd sing it if I knew the words, but I don't off the top of my head. Besides, they might start complaining. Neighbors come by and say, "Oh, that's singing about making all that racket." Doesn't kill you, makes you stronger. Chain rule. Get back on topic. Chain rule. The derivative of the outside part is cosine. You know what I'm not writing that I really should? I'm sorry. We're taking the derivative with respect to x. I'm sorry. Kelly Clarkson distracted me for a second there. Okay. Chain rule. F prime of g of x times g prime of x. So the derivative of sine with the inside part intact times the derivative of that inside part, why put it at the end when you can put it in the front? 2x equals the derivative of 2y. Well, we're taking the derivative of y with respect to x. Notice I just used two different letters in that, x and y. They disagree, so we're going to need this, and the derivative of that is a 2. We're going to solve for dy dx. This is incredibly easy. When we divide by 2, I'm not even going to show it. Why waste the ink? When you know this 2 and that 2, we're going to cancel. X cosine x squared. I almost read it like a fraction. Oh well. There it is. Isn't it pretty? Doesn't kill you, makes you stronger. Stand a little taller.